You drop a bright waterproof ball into the lake and it bobs happily on the surface. Today you'll learn how buoyant force works and how Archimedes' principle lets us predict when any object will float. Imagine a solid cube underwater. The water around it pushes on every face, but the pushes on the bottom are stronger because pressure grows with depth. That pressure difference creates a net upward push called the buoyant force. Sized exactly like the weight of the water the cube shoved aside. We write that as buoyant force equals rho water times v displaced times g, where rho water is density, v displaced is the volume of the kicked aside water, and g is gravitational acceleration. Let's compare blocks of the same size. A light wooden cube floats high because the weight of the wood is less than the weight of the water. It would have to displace to sink fully. A metal cube of the same outside volume is far heavier than the water it can displace. So gravity wins and it drops to the bottom. Now scale up to a ship. Even though steel is denser than water, the hull is shaped to move a huge volume of water aside. So the buoyant force can balance the ship's great weight. Picture a fully submerged box held under, then released. Gravity pulls down, buoyancy pushes up. If buoyancy is larger, the net force is upward and the box accelerates to the surface. Archimedes' principle in one line. An object in fluid feels an upward force equal to the weight of the fluid it displaces, no matter what the object is made of. Remember, buoyancy equals the weight of the displaced fluid, so both volume and fluid density decide what floats. Look around today and test Archimedes' idea with every boat, balloon, or beach ball you meet. Generate your own educational videos for free at eduvids.vercel.app.